Okay, can I continue? It is second week. Oh, really? I will check it back. Because I'm using Designer for the PowerPoint, so I'm not sure when I convert to PDF, maybe something is gone. I will check it back and upload it again. Right, thank you for the information. Right, I continue for the lecture. Is there anything else you want to inform? You can interrupt me during the lecture, no problem. All right, I turn on two computers so that I can see your chat while giving you the lecture. All right, so now this is the topic 3 on the data generation and analysis. So we are going to learn about form and type of data, what type of data that we have, and how the methods in data generation, as well as experimental design and statistical analysis, right? But for the statistical analysis, I will touch like in brief, because later during the practical session, later on, we'll have one session for the statistical analysis. All right, I hope that you still remember this basic step in research. So we are at this particular part, right? We are at this particular part. The data collection up to data analysis. So we need to know how to collect the data. So previously we already know the methodology on how to construct, what kinds of the methods are available in order for us to generate the data or to collect the data. All right. So now what kinds of data that are going to be generated, and how we collect that one, how we analyze that one, including all the storage part or managing the data and so on. Okay. So last but not least, later on is interpretation and reporting. All right. So what is research data? So research data is collected, observed, or created for purposes of analysis to produce original research results. So we need to have the data in order for us to come up with the results. So the results will not be generated if we don't have the data. Right? If we don't have the data, so we cannot have the results. All right. All right, so we need to have the data in order for us to have the results. So data for research can be in various forms. It could be in terms of the images. If you do some observations, so you can take the pictures, or you do scanning, observe through the microscope, or observe through normal observations using your eyes or using cameras. You can get the image of videos. Or in terms of numbers, so usually we collect it based on the numbers for the quantification data. Right? We quantify it based on the numbers. Then we write up, we write up the observation. That observation could be from the interviewing process and so on. Okay, so researchers might use survey data to observe human behavior, using microscopic images to observe structures, or quantitative data to evaluate performances. Right, quantitative data to evaluate performances. So, for example, you do several experiments, right? Then, from that particular experiment, you can see which parameters is actually increase the production, for example. So that kinds of quantitative data. So then we can have, usually in general, we can have two types of data that can be generated, whether that one is quantitative data or qualitative data. What is quantitative data? Data that we can quantify. So we have the numbers, we have the value, all right? So we have the value into it, and then we can analyze that in the value. I think I should turn on my camera, otherwise I don't feel that you can see my expression, okay? So I hope it will help you to keep focus. Okay, all right, so we need to have this, the difference between quantitative and qualitative. So if quantitative, we have the value, right? So we have the numbers that we do from the experiment, we do for the survey, we get the numbers. So how many people likes this particular product, or if they like to how many ratings, so we can evaluate that one into the numbers, right? So that is quantitative. We get the value, so quantitative. If qualitative, we don't have the value. Usually they give the opinion. People are giving the opinions, so we don't have the value to quantify their opinions. Okay, then we just describe it. We just report it as a result. Then we analyze that results and discuss it. So that is the qualitative. Qualitative does not involve the numbers. Okay. So qualitative data enables you to investigate why and how. For example, what do people think of navigation option on sites, or where you can have the opinions of the people, then you convert it into the quantity, right? Into the value. You can do that by asking them the scoring. So usually when I ask them the scoring 1 to 5, and so we get the value into that, then we can calculate the percentage, we can calculate the significant difference and so on between population groups of people. So that is quantitative. We still can get their opinion, but their opinion, we convert it into the value, right? So that is quantitative data. If qualitative data, we have their opinions, but we cannot convert that into the value, or we don't want to convert that into the value. We want their original opinions, not into the value. So that is a qualitative. So common qualitative collection methods are individual interviews. So we do interview individually, then we get their opinion. So we have respondent A, respondent B, maybe up to 10 people that we interview, then they give us opinion, then we can get something, and then we can see the pattern, all right? We can understand the situation. Or through the focus group, or observation, for example, watching how people interact with a website, or previous example that we go and watch people at the shopping mall and see their behavior, right? So there is the observation, or open-ended question. So usually if we provide them the question must be open-ended. So they cannot choose the option, but they provide their own opinions. If quantitative data, so there is through experiments or systematic observation. Right? Systematic observation is like you are using the thermometer to measure temperature each day. It's still observation, but that observation has the value. Okay. Number-based question on survey, how many tacos did you eat last night? You have the numbers or the value that you can quantify, or number-based question in the interview, or if you conduct the interview, you still get the value, right? Okay, next one is, this one is example of quantitative data. So you can see that we have the numbers, right? We have the numbers, then we can do the statistical analysis. So although this one is asking through the survey, so this one is asking through the survey. So we have several variables, demographic, types of group, then, but we can evaluate them based on the numbers, okay? This one is examples of qualitative data. For example, this one, they're asking the participants to demonstrate, the participant demonstrated they were actively making food choices to promote a healthy diet. The term healthy had a similar meaning for many participants, so they want to know in terms of their perspective. Participant perspective toward this particular one. So with avoidance of sugar being the principal factor, 4 participants gave the following answer when asked if they avoided any ingredient in meat alternative. For example, sugar, all the way. So respondent A say like this is respondent B, this respondent C, E, and this is respondent D. What they said has been reported as a result, but these results has been not discussed, but has been put some analysis to it, to analyze how the opinions are being captured. Okay, so this is an additional one. So there are so many. Later on, I will share with you the paper and examples of the paper, how the research has been conducted for the quantitative as well as for the qualitative research. Okay, so where the motivation is sales, respondent A describe how they are prepared to pay more. Okay. So this is examples of research data. So you can get the research data from the documents, spreadsheets, lab books, questionnaire, code books, experimental data, films, audio, previous one, right? photograph, images, files, and so on. There's so many. This is just some examples. So when we do research, we don't limit types of data that are available. As long as the things that we see can be generated, can be turned into as a valuable data for us to analyze and become the results and that discuss and then conclude our objective, then it can be used for the research. As long as it's following the ethical issues. So later on with my lecture as well, we will have the ethics for conducting research. All right, but I group the research, the types of research data into 4 groups. So you can have observational types of data. So you can have experimental data, simulation data, derived or compiled data. So what is observational data? It is collected using methods such as human observation. So you do the observation, so you can get the observational data, right? Open-ended survey or the use of instrument or sensor to monitor and record information. For example, you have the gas analyzer. So that gas analyzer you put at the car exhaust, right? Car exhaust. But you don't do the experiment, you just put at the car exhaust several types of cars, and then you let it happen, right? They drive, and then you collect the data from analyzers. So that can be as observational data as well, right? You observe what happened naturally for the car. So you don't do the experiment for different fuel or different and so on. So you don't do that, it's just normal observational data. So data from natural occurrence without manipulating the factors, that is observational data. So data is collected based on visual observation or measurement of the observation. Okay, so if there is the sound, so you have the sounds that you measure. Okay, for example, in different areas, you want to measure the intensity of the sounds for different areas. So whether they have different sounds intensity or not. Okay, so that can be from the observational. So this is examples of results from observation data. So this is rate of ice melting in Antarctica or biodiversity changes in contaminated area, effect of ice melting on sea levels or lung cancer patient among smokers. So you don't do the experiments, but it happened naturally, and then you collect the data from that. This is more observational data, so you can get like food supply in Malaysia. So you don't control, you don't make the experiments for the food supply. It happened naturally, so you collect the data. So that is considered as observational data, all right? Or production or yield quantities of rice, paddy in Malaysia, or production share, and so on. Okay, so this one we can get it from FAO stat. All right, so this is examples of the observational data as well. When you do the experiment, factors affecting consumer attitudes to fungi protein, because when you do the survey to the population, you actually don't do the experiments. You do more on the observational data, but that data is being turned into the survey. All right, it's being generated through the survey. You collect through the survey, so you can get these kinds of data. Okay. Next one, the second one is experimental data. So what is experimental data? It is collected through active intervention by the researcher to produce and measure change or to create difference when a variable is altered. So experimental data typically allows the researcher to determine a causal relationship and is typically projectable to a larger population. Experimental data involves manipulated variable to be tested. So the data generated from the analysis. So usually when we do the experiment, we will have the variables that we control, right? We have the variables that we already determined. So this is control variable, this is manipulated variable, this is responded variable. So we already determined that kinds of situation so that we can do the experiment and generate the data so that the data that we can get represent the situations that we want to achieve for the objective. Right, so usually the data that we get from experimental data is through the analysis. So if we do the experiments, so at the end we need to have the analysis in order to collect the data. So that's why I already mentioned or explained last time. All right. So this is how we do the experiment in order to collect the data. So definitely we must have the experimental design. Then inside the experimental design, we must have the methodology. Then we have the analysis. After the analysis, we get the data, and then we transform the data into the results. Okay, so this is very straightforward. Data results from the experimental data. So when we do the analysis, all right? So when we do the analysis, we will get the data and then we convert it into the results. So these kinds of results, right? So that we can see something happen or some of the pattern from our experiment. So what analysis need to be conducted and how the experiment should be designed to generate this result. So what are the analysis that we need to conduct? Anyone? If you want to generate these results, what analysis that we need to conduct? Okay, Shamila, I will answer that. So what analysis need to be conducted for this particular graph? You see this graph? We have sugar concentration, we have time. Yes, we need to do the analysis to determine the sugar. All right, so what is the manipulated variable? So our manipulated variable is wet substrates or dry substrate. So we need to conduct two different samples. One is wet substrates, another one is dry substrates. And then we do the saccharification process because this one is mixtures to conduct the saccharification process. So we do the saccharification process. At the end of the process, we will get the sugar. So the sugar we analyze every day. All right, so then we can get this data. So the analysis is the sugar concentration. The manipulated variables is this one. All right, and we check every day. Now, the control variables might be the amylase and cellulase concentration, the temperature. There are so many control variables, others for the processing part. The working volume, everything are controlled. Only these things are being manipulated, right? Only these two. And the respondent variables is the sugar concentration. Okay. So how to know if the available data is valid or not? Okay, so now usually this one for secondary data, so we need to get from the what we call reliable sources, ministry data or data that has been evaluated, by the organization, or those that has been published. So those data we can compile for the secondary data and we can use it to further analyze. Okay, so if generate from ourselves, so there are so many what we call approach in order for us to determine whether that data is valid or not. Okay, most of the time we can use the statistical analysis. So based on the statistical analysis, we can see whether there is error or not from our data. So if there are a lot of error, so might be due to our experimental designs and so on. So we need to remove that one. If we get that data, for example, from the interview or from the what we call from the survey and so on, we can see the bias, outliers. We call it off outliers. Among the whole, there are some little amounts of people are answering out of the normal distribution, So that is considered as outliers. So that data might be not valid. So we have the rights to remove that data. For example, usually this is usually happen. So we have the survey form, then we're asking to rate between 1 to 5, right? So 5 is strongly agree, 1 is totally not agree, for example. Okay, so sometimes the respondent mistakenly reading the question or that particular one, they don't put the focus into that one. So some of them might think that 1 is strongly agree, so they put 1 for that one. So we can see that kinds of outliers into our data. So that's why we need to have some amounts of sample size, so that the data at the end of the study, we can determine the outliers. Then we can remove these outliers data. So that usually happens. If we do the experiment, we do triplicates, 1 is outliers. So definitely we can remove that one. Or when we conduct the statistical analysis, there are a lot of error. Standard error or standard deviations are too big. Standard deviations is too big, or standard error between the populations are very huge. So then they might have some error in our experiment, whether our analysis or whether our techniques or whether our substrates, other factors. So yeah, those things we need to analyze. Okay, so then if we know that data is reliable or to be used. If not reliable, then we need to repeat the experiment again. But when we repeat the experiment, it gives the same thing, then that is the real situation. Okay, so then we can accept the data. Otherwise, we need troubleshoot until we get the correct data. Clear, Shamina? All right, so this is an example as well for the experimental data, right? So if this one will have a lot of analysis to be conducted, so we need to conduct in soluble lignin concentration, soluble lignin or total lignin, then this one can be calculated. All right, so this is the manipulated variables that we can use. Okay, this is the next one. The third one is simulation data. So what is simulation data? It's data that we generate by imitating the operations of real-world process or system over time using computer test model. So usually if we want to have the simulation data, we need to do some using the computer to generate the simulative data, all right? So for example, to predict weather condition, economic models, chemical reactions, systemic activity, and optimization condition, so that can be generated based on the previous data we put into the simulation, then there will come out some simulated data. So that simulated data we can analyze and predict for the future, for example, all right? Or predict people behavior. We can do the simulation data to predict the people behaviors. For examples, within the next 5 years, what are the intentions of the people into certain products? So whether they are going to like it or not, or for the Facebook's, TikTok or Instagram, based on the data that happening now, so they can predict in the future, or the future job. So those things are simulation data for the future. So examples of the computer test model, you can use Design Expert. MATLAB is very complex. SPSS, SSS, those are statistical computer test model that can generate the prediction, right? They can predict the what happening if we do this particular input. So what happened next? Okay, so in terms of the analysis, to analyze the simulation data for bioprocessing, biotechnology that using bioprocessing, we can use RSM, response surface methodology types of methods. RSM, we have so many designs of experiments. We can have CCD, we can have packet bookman, and so on. Or artificial neural network. Artificial neural network can be very simple or can be very complex. The AI also use artificial neural networks in terms of analyzing data and predict the results, right? Or two-level factorials and so on. Okay. So that's we call as a simulation data. Right? How we analyze the simulation data. So this one and examples. How to do the simulation data. So ultrasound assisted extraction, we use this one. So we use the CCD or different types of method designed in order for us to conduct the what we call pre-experiments in order to come up with the simulative data. So then we'll have this one, then we can generate the simulation. This is types of optimization. All right. So parameter estimation, based on the previous data, we can collect a lot of data from the secondary data, for example, from the previous journal, right? So we can collect all of the data, then we use that data, and then we analyze it, and then we simulate it. So we will generate new data, new simulative data. That new simulative data, we can further analyze and come up with results or prediction, right? For the simulation. All right, the fourth one is derive or compile data. So we can also derive the data. So how we derive the data? So we create new data through some sorts of transformation. For example, arithmetic formula or aggregation. I haven't do this one, previously. So I'm not sure how it's happening if in a real research, how they actually do the methodology in order to generate a new data from the different data, all right, to derive the new data. So, but I provide you these kinds of information based on my readings. So, for example, combining population data with geographic data to create population density data is considered kinds of derived data. So we have different data, all right? So when we mix together these different data, they come up into new data, all right? So that new data, we need to analyze data before it's generated into the results. Okay. All right, so I give you 5-minute rest, then we continue next one with the data collection. Okay, class?
Okay, Prof.
All right. Okay, class, can we continue?
Yes, Prof.
All right. So this is the data collection. How we collect the data. So data, collect or generate your own data. So this one we call it as primary data. But if you're using existing data, so we call it as secondary data. So if you want to collect or generate our own data, so we can do it from experiments or through the observations, even through the simulation, right? Just now. But if secondary data, we get it from the trustable sources. Okay. Actually, this one is like mostly repeated one. So if we want to collect the data, we need to have experimental design, methodology, analysis. What are the data being generated? Then the results. Okay. So if you're using existing data, so we can get it from other researchers or government data, organization data, data repositories, and so on. So this is an examples of data collected from palm oil industry. So we don't do the experiments, we go and collect the data from the palm oil industry. So then EcoB do that, or the palm oil industry are providing this data to EcoB. So then they come up with this particular kinds of data, right? Including this one as well. Right, so this one we don't do the experiment with, but we're using the existing data. So what are the data source for existing data? We can get it from the published scientific articles, or we can get it from the FO stat, we can get it from DOSM, ministry data, or bioinformatic database. Even bioinformatic database, we have like gene bank, DNA, and so on, protein structures, all are from the bioinformatic sources. So that's considered as the secondary data because those are being uploaded before. Right. But don't forget, we can get it from the organization data as well. For example, like palm oil industry or pineapple industry, those agencies are doing the data collection. So we can get that data from them for us to do the analysis of the data so that we can generate some results from it. Okay. So this is data collection in research. So when we get the data, so analyze the data set into one method. So if it is interesting, so we can go further. If not, then like the data is valid or not valid, or interesting or not interesting. So whether that data can be used further or not. So we need to determine based on our capability of analyzing data. So we need to analyze that data, right? The data set. So if we have big data, so later on we will learn that one with Prof. Yunus on how to analyze the big data. So, but usually experimental data, observational data, or questionnaire data. So if that data is interesting, so we can proceed further to define our hypothesis. If not, then we need to recheck and analyze it again. Right? So if okay, then we can do the hypothesis, including criteria for significance. Then we can do new data collections needed. Then we can analyze the data based on our hypothesis. And their hypothesis is generated based on the objective as well. So if for me, we're evaluating based on our objective, whether the objective can be achieved or not. But the hypothesis is we set in our mind. Okay, so analysis according to the hypothesis. And then if valid according to the criteria, then the hypothesis can be accepted. If not valid according to our criteria, so we can reject it. It doesn't matter whether the hypothesis is rejected or accepted, but at the end, there are still the results. Right? Positive results or negative results, it's still the results and it's still valuable. So don't afraid with the negative results, because negative results are still valuable for the other researchers, so that they will know and they consider that kinds of experiments, that kinds of data to be kicked off from their next future design. So we know that this one doesn't work. So in the future, we are not going to repeat the same mistakes. So negative results are still valuable. All right, the next one is how to keep our data organized. So in the course of your research, you will often create multiple versions of data files, and we will need a way to keep track of it, right? So it's very important when you do the research and you collect the data, because the data usually very raw. They don't have a lot of they have a lot of information inside, but we don't analyze. So we usually forget about this data is represent to what kinds of situation, right? So usually we just get that raw data, and that data after certain time we might forget that data is represent to what kinds of situation most of the time. So when we get that data, so we need to label that data accordingly. If digital, so we need to label the file accordingly. If inside the sheet we have so many, right? Excel sheet we have so many data inside, so we need to arrange them accordingly so that we don't forget it, right? Including the date, including the time. So if we do the experiment, we know that data is referring to what kinds of experiment, right? Previously, like when I did my study for my PhD, so I have a lot of data because I keep on running the experiments, multiple types of experiment. This week I'm doing maybe different kinds of experiment. The following week I use different kinds of experiment. I'm collecting data. So if I don't properly arrange that, everything will miss up, then I will forget that data is present, because all arranged into the same, got date, got the results, but their results are different definitely, but the way they arrange all are the same between the experiments, right? The time 24 hours, every 24 hours, the time are all the same. The result, I have the acetone, I have the butanol, I have the ethanol, so all are the same, right? It's just that the values are different because of I conducting different sets of experiments. So if I don't label it properly, right, so that might, yeah, I might confuse to how to refer that experiment. So labeling or organizing that kinds of data are very, very important. So in your dissertation, maybe later on, so you also collecting the data from several sets of peoples, for example, different groups and so on. So you need to know on how to manage your data academically, so that you don't get confused. And when you analyze the data, you will generate the correct one. So you can arrange your data according to experiment or date of experiment. Don't delete your old data unless you are sure it is a waste, right? Although at that particular time, you think that, oh, there's something wrong with this particular data, so you might not need to use that in your results. But please don't delete it, right? Keep it your data in whatever, whether it's good or not, until you finish your study. Or even if you finish your study, if you are capable to keep that data, just keep that data. It might give you some reference in the future if you somehow you really need to check back what are the mistakes over that, so you can refer it back. Or sometimes after certain analysis, then you need to change your decision, so you can change your decision. All right, so after certain times, even after you finish your study, even my study for my PhD, I still have my previous data that I keep, raw data in Excel files and so on. I still keeping it so that in the future I can refer it back if there is needed to refer it. Okay. So even it is not even is useless data at that particular time, so please keep it. So always have a backup for your data. So now we have a lot of cloud and so on, but even we have cloud, so something might happen to that. So we should have some backups here and there. Okay. So for data analysis, so what is data analysis? So once you collect the data, right, from many experiments, then you need to analyze that data. Why we need to do analysis of data? So that we can see the pattern, so that we can simplify that into the results. From that data, if raw data only, we might not be able to come up with the conclusion, what happened, right? So we need to have that data, we analyze it, and then turn into the results, whether the graph or whether the table or different types of graph and so on, right? So we can analyze it and create it into the pattern. So it is the process of systematically applying statistical and or logical techniques to describe and illustrate, condense, and recap and evaluate the data. So we do some analysis to that data so that we can come out with the results. Most of the time when we do the data analysis, we need to implement or we need to apply the statistical analysis. It's very important to have the statistical analysis into our data. Very, very important. Because if we don't apply the statistical analysis, we are not sure whether that data is reliable or not. As what I mentioned, reply to the Shamila question just now. If you want to see whether that data is reliable or not, so we conduct the statistical analysis, then we can see the error or the significant difference and so on. Or we can confirm the pattern. Sometimes we can get the figure or the chart, but from that chart, if we don't put the statistical analysis, we're also not sure whether they have some significant difference or whether that data is reliable into the particular conditions or is contribute to the whole population. So we need to do some statistical analysis too. So that based on that statistical analysis, we can confirm our conclusion. That is very important because we want to conclude something from the results. It must have some analysis over there. So that statistical analysis are very important to ensure that our conclusion is not misleading. So an essential components of ensuring data integrity is the accurate and appropriate analysis of research findings. It's very important. Sometimes the data analysis itself, we mistakenly do the data analysis. Choosing different methods of statistical analysis for that data, then at the end of the day, we're actually concluding something that is wrong. For example, if we use different statistical analysis to do this particular data, this one we use Tukey test or instead of ANOVA test, instead of ANOVA, or student t-test instead of Tukey test and so on. All right, so we are using different statistical analysis, then they will give different p-value, whether it's significant or not significant. Actually, we should use ANOVA, but we are using different types of statistical method. So that kinds of thing also should be put some notes over there, some attention. So improper statistical analysis distort scientific findings, mislead casual readers, and may negatively influence the public perceptions of the research. Okay, so when you want to analyze your data statistically, usually very simple one, you will do for the average. I mean, you have replicates of it, so you determine the mean, right? You have replicates, several replicates, at least 3 replicates, or duplicate. If you already confirm all your methodology for many times, you do it duplicates, you get the data of duplicates. No problem, duplicate, but duplicate you must confirm or confidence with your experiment already. For example, so many sets you already run duplicates and you already confirm. When you run duplicates, you will get almost similar result. It should be no problem. Then you can get the average. And as standard of it, you can also determine the standard deviation and also the standard error. Later on, when we learn about the statistical analysis, we are going to differentiate between what is the difference between standard deviation and standard error. When we need to use the standard deviation, when we need to use the standard error. Usually for the normal data, we have the average plus minus with the standard deviation because it's referring to the replicates that we use. We have a lot, huge standard deviation, and the standard deviation error bar is very huge, or plus minus is very huge. We might see something wrong with our analysis, during the analysis process. But if the standard error is a lot, the entire experiment might have some problem if the standard error is. So then we also do analysis of variance. This is like very common. We have different kinds of ANOVA that we can do. So this ANOVA will actually determine the significant difference of the sets of experiments that we conduct. We can also do the student t-test or Tukey test and so on. So if you want to read further about the statistical analysis, you can go for this particular article and go deep further to try to understand by yourself. Because later on during the practical session for the statistical part, we're going to learn it again. Okay. So this is examples. Again, I'm still using the same what we call article, factors affecting consumer attitudes to fungi-based protein, a pilot study. All right. So this is examples of data after analysis. So you can see that they put some statistical analysis to it. Right? They put some statistical analysis to it. This is the data we got it. Okay. So this is basic statistical analysis. So you can do like obtaining the what we call the average. So this is the average. This is the standard deviation for different kinds of components after you run your experiment. So you can see that using the standard deviations into the graph, it is compulsory. Why we need to have this error bar into our graph? Very compulsory, because this one will represent that we already did some statistic analysis to our results. And we can see this one, this within this particular range, there actually no significant difference, right? There is no significant difference. So we can stop at any part for this one, at this particular part, if you want, right? Because here the stationary phase has no significant difference, so we can put it to the range for this particular part, right? Or this is based on our observation through the standard deviation. So we can also analyze this one using the N1 part. So we can see at the end of the analysis, we can see that all the results are no significant difference. Okay. Even you compare, if this one you comparing between each of the plot, so this one you can see that there is no significant difference because the plot or the error bar is within the attached to each other, right? All right, so there are numbers of issues that you need to be cognizant of with respect to data analysis. You must have very good skills to analyze. So when you get the data, to manage your data academically, how you manage your data, how you put into the Excel, and then how you analyze it. Okay, arrangements of data are very important as well, because the way that you arrange will help you how you analyze the data. And then you also need to know how to select data collection methods and appropriate analysis to do that. Drawing unbiased inference, so you want to remove the unbiased one and so on, right? So how you're going to do that? So inappropriate subgroup analysis, following acceptable norms of discipline, determining statistical significance, right? Lack of clearly defined and objective outcome measurements, providing honest and accurate analysis. So when you do analysis, sometimes you will be triggered to remove those not outliers, but negative data. So you are triggered to remove those negative data so that you will get those positive only, right? So sometimes that will be misleading into your data. So manner of presenting data, the way that you present data, how, whether it's appropriate to be put into the table or whether it's appropriate to be put into the figures, right, and so on. So how you're going to evaluate that one so that it's suitable to be presented. Okay, so data recording method, reliability and validity. Okay, in terms of the data, whether it's stable, the data is stable. If you do your experiment, you are the one only know whether the data that been generated is stable or not. Even if I have the students are conducting the research, all right. So I can also evaluate that one to know whether the data are stable or not. That's why we need to keep on monitoring the data generated by the students as well. So because they will show the pattern. Previously they done this way. The next one they done adjust some variables or parameters, so they get different data. But the second data and the first data have some no connection. There is no connection between first and second data, where it should be have some connection over there. So they might have something instability over there. So need to troubleshoot and repeat it again, adjust the experimental design and so on. So there's a norm in the research to troubleshoot the situation so that the data have the consequence or the correlation between the first set, the second set, and so on. Otherwise, you cannot see the pattern. And whether the data is reproducible or not, after we do a lot of experiment, at the end we conclude something. Okay, we use this parameter, we can get these kinds of the products concentration. Then we try to repeat it again. We must at least get within the range. Within the range, how we determine the range? Based on the statistical analysis. We can get statistical analysis will give us the range. So when we repeat it again, so we will provide within the range. So that will give the accuracy of the data. All right, we are very fast today, but no problem. After this, we are going to go through the samples of the paper that that I will share with you, and like this that one. So this is almost finished. Presenting data. All right, although simple, the preparations of tables and graphs should follow basic recommendation, which make it much easier to understand the data under analysis and to promote accurate communication insights. This is very important, because why? When we have the table, because that results or that report will be read by the other people, right? So we must ensure that not us only understand, we must ensure that other people who read the report will understand as well. That's why the first thing first, when we want to analyze the result and analyze the data and generate into results, we must determine whether we want to put it into the table, suitable to be put into the table, or to be put into the graph in terms of the figures and so on. Okay, so we must confirm that one first. So we want to put in the table arranged must be properly arranged so that it will be easier to understand. Okay. So the most important is the identifications of data in which the researcher is working, as well as a clear and synthetic descriptions of this data using graph and table. So graph usually used to present the pattern or the profile, while table mostly used to differentiate or to compare where the value is important to show up. Okay. So usually if you want to use the graph, right? So the graph will show the pattern, right? If increase or decrease in terms of the comparison between the group, right? The groups of data, right? So if we want to compare that one, we see the pattern. If it's important to show the pattern, then we present it into the graph or the figures. But if the value, the numbers are very important, so we can present it into the table. Especially the table, we want to differentiate between several groups, and then we can see something in terms of comparing in terms of the value, so we can go for the So imagine the statistical data without a definite presentation will be burdensome. Okay, we do all the analysis, but at the end we have a very poor results presentation or data presentation, then meaningless. It's part of the science communication, all right? Science communication, we communicate with the public through our writing as well. So that through writing, that writing must be understandable by the people out there, or within the people, the community in that particular area. The other people should understand what we write on. Okay, so data presentation is one of the important aspects in statistics. Presenting the data helps the user to study and explain the statistic thoroughly. So data presentation is defined as the process of using various graphical formats to visually represent the relationship between two or more data sets so that an informed decision can be made based on them. For example, just now I mentioned to you, if we use the graph, for us to see the pattern. So when we see the graph, we already know what is happening for that particular situation. We see the graph, we already know what is happening, so that we can evaluate, discuss, and come up with some knowledge from that. Whether this particular situation had been increased, the experiment had increased the production and so on. Based on the graph, we see the graph, we can evaluate. Okay. The same goes to the table. We can come up with some information over there. So that is important of the graph and also the results. If we use the data or the raw data with the analysis, we cannot generate some knowledge over there. So from the results being generated, so we can see the patterns and so on, so the knowledge can be derived. So how we can present the data, so whether that data can be in terms of textual, not only table or diagram, we can also present the data in terms of the text. So we write down the text. Right? So textual presentation of data means presenting data in the form of words, sentences, and paragraphs. Right? So whatever method that you choose, your data should be presented in the simplest form so that the reader can be easily draw meanings form of it. Right? For example, just now when I show you examples of the qualitative results, so they will put the respondent response opinions. So that kinds of results should be, although it's textual results are presenting the data in terms of the text, but that been arranged or grouped accordingly so that we can capture according to the what we call to the needs. For example, if you want to see the their opinions towards the price, or their opinions towards the compounds or the products. So they will have grouping into that. We cannot just mix up. We still need to do some analysis. We need still to present that the way that we present how we project that results should be arranged properly. And maybe we italic the text, or maybe we put the bullets for that particular results. So we can do that in terms of the textual. So the researcher should choose a method of data presentation after clearly understanding the advantages and disadvantages of using that. Textual advantages or disadvantages. So usually we use textual to elaborate. So we interpret data more elaborately during the presentation. That's why I showed to you for the qualitative data. It's more the elaborations of data. Or sometimes you don't put the table, but you have the value, even though it's not qualitative, it's quantitative. But the data is not suitable to be put into the graph or not suitable to be put into the table. But it's just enough for you to write down. For example, you have the data compositions of starch, 3 types of starch: rice, corn, or anything else. Right, the starch inside. So only that thing you no need to put into the table. So just mention it. It's still textual representation, right? Textual presentation, but it's still the results of the test. Just that you don't project it into the graph or do project it into the table. It's still acceptable that way, as long as we can understand. That is the best way for you to show it. Because if you put the table, maybe if you want to publish, they have limitation numbers of tables, so you cannot make it into the table because it's just a small little results inside it. Not very important to compare, just to mention. So you just can put it into the text, right? So you can use also most of the time use for the qualitative, because qualitative we have the opinions of the text. Emphasize, you want to emphasize something. So if you put into the table, might not be able to emphasize that result. So you emphasize into the text, right? Or small data, as I mentioned to you, small data sets. Example, there are 30 students in the class of 20, of whom are girls, while 10 are boys, right? Just so you don't have to put this data or these results into the graph, into the table, right? So just enough for you to mention. So points to ponder when using textual data. So the researcher should know the target audience who are going to read it, right? So the researcher should also use a language in the presentation of data that is easy to understand and highlight the main points of the data findings. Okay, because we write the report, when we read, we must understand that the readers will read it, so we must put some intonation to our writing. When we put some intonation, so it will help people to know whether this one is being highlighted. The data should be highlighted. Very important, right? So that intonation can be project or can be presented into the text as well. Right? If you keep on writing, so you can aware that when you write, so you have the intonation in your writing. Right? Same goes like when I'm speaking, they have some intonation. It's not just flat. So same goes to the writing and science communication. It goes to the writings of the paper or the report as well. You must put some intonation. It cannot just be bland, flat, or lengthy sentence, or too short, everything too short, don't have connection. You must have some art of making it nice. So the author should also use wording that does not introduce bias in research. Avoid the use of bias, slanted, or emotional language. You can have intonation, but cannot be emotional in your language. Cannot be emotional. You can put your to highlight something or to strengthen something in your language, but not emotionally. Or if slanted, then yeah, people will keep will be boring when reading the report. So accuracy should be maintained in presenting data, and the numbers and percentage presented in the textual data should be reviewed to avoid any mistakes in the presentation. Sometimes you have the data already in the table, but you want to highlight or emphasize in your text. So when you emphasize in your text, you might ensure that the values that you use in the text should be the correct one. as what put in the table. Or if not put in the table, not put into anywhere, like the previous one, or this one. So the numbers all are correct. Don't get confused, because when reading this one, they will have, we don't arrange it into the table and so on. So it might be confusing. So whether it's 30 girls or 20 boys and so on. So you must arrange it properly so that don't get confused. Because I mentioned this one because usually not only students, me myself always did that kinds of mistakes. So we need to review that one. When we review the text, our text, we must ensure that those values. All right, to make it easier for the audience to comprehend the important points in data, the researcher should avoid unnecessary details. Too much detail can make it difficult for the audience to concentrate on the key points in data. That's why writing in terms of the textual, you should have some art of doing it, right? So you cannot be like so lengthy that put in all the details, especially into one sentence or into one paragraph, because we will run off from the attention to which point that should be highlighted. So we need to have the intonation into our paragraph so that we know what we are going to emphasize based on that, which value should be emphasized, so that the audience will not get different perception, different conclusion. After, at the end of the reading, they will also conclude something. Oh, this research actually did something and they managed to get these kinds of things. But if you emphasize something else that have something else that is more important, but emphasize something else, so they might derive different conclusion by the readers. So it's very important as well for you to ensure which one should be highlighted. Too much detail also not good. If you have a lot of details, important points, so you must properly arrange. Maybe the first important points into the first paragraph, the next one, second paragraph, and so on. Okay. So do not repeat the same point again and again. All right, this is a lot of time. You already mentioned it into the introduction. When you come to the discussion, you repeat it again. Although introduction part and discussion part is far away, but like for me, although the examiners reading the thesis or reading the report, we can recall that, oh, this one already been mentioned in the introduction, then we need to go back somewhere else. So we need to go back and find some duplicative information. So if already informed, so no need to inform it again, especially so many times. In the introduction, then later on, you want to emphasize that thing, so it's triggered you to repeat many times, to repeat it many times, again and again and again, because you want to emphasize, but somehow it's not necessary to do that. Just emphasize it one time, the next one you just need to discuss it. So please avoid reporting information. Same goes to the literature part. Although the literature part, we put several sections, we try to arrange it several sections. Sometimes we, because our knowledge are limited to that particular part only, we don't read further, so we keep on repeating the same information. So that is dangerous. Why we don't want that? Because it will trigger the examiner to see that you are not capable of evaluating more information further. Okay, so try to avoid those repeating information into especially into the thesis or this dissertation. Okay, if you already mentioned it in the introduction, so when it's come to the next one and so on, so you should avoid the same information. So try to shorten longer phrases where possible. Right? So if too long, a lot of points inside, so try to simplify it or make into several sentences. Right? Or sometimes the information need to be combined, so you need to combine it. So one mistake that often researchers make is to use general descriptive words like too much, little, exactly, all, always, never, must, and many more. So you must try to avoid these kinds of statements as possible, right? For example, when you mention that too high, the products that you produce is very high, you must come up with the value. What is the very high? Because we do not know. Very high in terms compare with something. Is it higher or lower? If very high is so descriptive, we cannot evaluate that value. Okay? Or many more, or etc. So try to avoid that. If only have 3, then mention it 3. Okay. Only if there are a lot, but you have 3 most important, so mention 3 most important. Okay. Among the important points are 3 important, for example. Don't put the best data for this one are and many more. Okay, you try to avoid many more. Okay, so avoid decorative language or make sure that you use scholarly language in your data presentation. They happen to my students a lot of time as well. We try to use like flowery language, too flowery. I feel so tired to read a flowery language or decorative language. Berbunga-bunga, we call it like berbunga-bunga. It's too flowery. There are so many connection in furthermore, in order, so many things. That's not straightforward. In research, you try to use straightforward and scholarly language. Make it more scientific explanation. Don't use like, go here, go back, go. We cannot find the points. Just straightforward to the points. Scientifically explain. Just put scientific. If you want to discuss, scientifically discuss. You want to refer, scientific, refer to something. Don't reduce the decorative language. Okay, not too flowery. So examples. This is examples. The oil palm and truffle bunch composed of 40% of cellulose, 20% of hemicellulose, 25% of lignin, and the remaining are ash extractants. Right? So this is textual, straightforward information about the compositions of empty branch. Okay. So based on the survey, 92% of respondents like the texture of biscuit made from watermelon peels. Very straightforward. Okay. Right. We go for the next one, which is table or tabular. Okay. After textual, this one is tabular. All right. Naimullah, how much data do we need to present in our dissertation or research? Is it our research must be in a big number of samples? Not necessary. Not necessary. I cannot because we need to have the when we design the experiment, we need to know our time limitation. So when we design the experiment, we need to ensure that when we do the analysis, when we do the experiment, the data collection or the research, the study, must ensure that it's capable to be finished within the time frame given, right? Within the time frame given. How much data, for example, if you need to find the population, there is a way of determining the sample size. For example, if we have 95% confidence levels, we need to have 95% confidence level. We set the population. For example, if we go for Malaysian population, so how many sample size for that Malaysian population? So if you cannot get that Malaysian population, so you must reduce the targeted population. For example, among the university students in UPM, or among the researchers in UPM, or among the researchers from the RU, or among the consumer at the IOI City Mall, or among the Facebook user within this particular age, 40 to 50 years, for example. So we limit the population size, so that when we use the sample size, don't have like too many. Okay, the numbers of sample size. In terms of the data, right? In terms of the data, determining how many sets of data that you required, so that will be determined based on your objective, whether your data is enough to conclude your objective or not. So if not enough, you need to add further. Is already enough, then okay. Well, sometimes it's enough, but you need the supporting data. So you need to add further with the supporting data. So it depends on how you design your experiment. Your main data capable to conclude your objective, right? Your main data or your main results capable to conclude your objective. But somehow when you discuss, they have some lompong here and there. So you need to have some supportive data to confirm of something or to strengthen your conclusion. Then you need to have some supporting data. It depends on your experiments or your research design, right? Okay, clear, Naimullah?
Yeah, clear, Prof.
Okay, so next one is table. Okay, I think this one I repeat it many times. This is one of the most popular use of forms of presentations of data, as data tables are simple to prepare and to read. So when you read the table, you actually know this one is comparing to something. So you know which one is higher, which one is lower, which one is actually normal as the others and so on, based on the data. So why you need to present the data in table to simplify the complex data. You have a lot of data, so you want to simplify those into groups so that you can compare it academically. So you want to simplify that one so that you can capture the information from that particular data. So to bring out essential features of the data, as mentioned to you just now, or to facilitate comparison. Usually when we do the table, we want to compare something, right? Advantages and disadvantages. So we put it into the table, we can see the advantages and disadvantages academically. To facilitate statistical analysis. So when we do the statistical analysis, we need to arrange the data into the table as well. Then we can do further analysis and saving space. Write down all of that one into text, definitely will be troublesome. But limitations of data, lacks of description. The table represents only figures and not attributes. It knows the qualitative aspects of the text. Incapable of presenting individual terms. It does not present individual items. It presents aggregate of the data. So it needs special knowledge. The understandings of the table requires special knowledge. It cannot be easily used by a layman. If you have the table, then sometimes you need to evaluate further into the text textual. You need to have some textual in order to elaborate the table. You cannot just have the table. Then normally for me, if I read something, the table, that I already be familiar with that, so I don't have to read the text a lot. Okay, I just go through the table, then I already understand what the data is represent. That I just read the text just to compare it. But for the layman, maybe they will require a lot of explanation from them. So this is how to present the table. All right, so you might have this kinds of situation. A lot of inside here. This is the main body part. Okay, this is the parameters values, the criteria, the characteristic, the compositions. Those you put over here. This is usually you put for different variables. For different variables you put over here. So that it will be easy. Sometimes you will have the compositions is over here, but the variables is over here. It's okay, depending on how important of it. Because usually this one, we will see this one first, and then we will try to evaluate with this. Okay, then we can see the results inside. This is an example, right? So you see that a lot of we put the variables over here, but different one is over this particular one, right? Demographic group. Right? This is the same examples for the factors affecting the consumer just now in UK, in Europe. All right. This is another different tables, right? So you can have arrange the table accordingly. So can you put this one correlation variables here and then Spearman correlation here and then FTS all the parameters over here? It will look messy. Okay, so it should be arranged so that it doesn't look messy and easy to understand, because we go down over here and we see the hidden over here, right? Okay, sometimes we can also do this one, because this one will have many points. So depending on how suitable to arrange them. So if we put the star cellulose, also possible. I also did last time. This one is the composition. We have star cellulose, is until the final reference. This one is different location. It's also possible. In this case, it's not that very strict. As long as when we read, we can actually compare. Because in this case, we are going to compare between this one, cellulose, this one, hemicellulose, this one. We are not comparing starch towards cellulose or towards hemicellulose. Diagrammatic. So this one, if you want to convert it into the diagram. So it is a technique of presenting numeric data through pictograms, cartograms, bar diagrams, and pie diagrams, and so on. It is the most attractive and appealing way to represent statistical data. So diagram helps in visualize comparison and showing pattern. So usually if you want to see the pattern, we convert it into the diagram. So advantage of diagram, attractive and impressive. When we see the diagram, we can actually see what is happening in terms of the pattern, right? So the data presented in the forms of diagram can attract the attention of even a common man. Okay, so but if we have the tables, we need to evaluate the values. We need to put more attention to evaluate the data. But if we see the diagram, it's much more easier to be analyzed, to get the information of it. It's much more attractive to see than the table. The table will have a lot of information that trigger our brain to think a lot. Okay, so it's easier to remember because it's diagram instead of values in the table or in the text. So diagram have a great memorizing effect. So the picture created in mind by diagrams lasts much longer than those created by figures presented through a tabular forms. Diagrams save time. They present complex math data in simplified manner. The data presented in the form of diagram can be understood by the user very well, right? So diagram simplify data. Diagram also useful in making comparison. Not only table, the diagram also can make comparison. For example, if you have bar graph, right? So we can see clearly difference between each data set. Or if we make pie chart, we can see differently which one is bigger, which one is smaller. As compared to when we put it into the table, we need to see or evaluate the value. But if diagram, we can see it directly. So it's more informative. Diagram not only depict the characteristics of data, but also bring out other hidden facts and relations which are not possible from the classified and tabulated. How to prepare diagram? So we must have title, and every diagram must be given a suitable title, which should be small, self-explanatory. So the size of diagram should be appropriate. It's not too small until very difficult to capture the diagram, or not too big. If too big, it looks like something wrong with the diagram. Okay. Scale. If you use the diagram instead of the scale by diagrams and so on, so the scale must be appropriately arranged. Whether decimal point, even the decimal point, if you use, is it appropriate to use 3 decimal point in the diagram, or is it just appropriate to use no decimal point? It depends to us. So we can see that one, how important of that data to be put into the scale. So usually we just use 1 decimal point or 2 decimal point. If a lot, then we may see. Okay. Index, when 2 or more variables are presented, and this is legend. If you use the Excel, then we need to put the legend, and then we need to select a proper type of diagram, whether we want to use line diagram or bar chart or pie chart, those things. Which one is the most we want to project our results. Okay, so this is an example. So we have a lot of data from various people. So we tabulate it here, and then we try to find the correlation. So we can see the R square. R square is not that too high. So we need that there's not so many significant difference between. Okay, so we can also tabulate this one into this. We can have the score. Usually we can have the score 1, 2, 3, 4. We can put it into the normal pie chart. But if we put this one, we can see the connection between the healthy part, safe, natural, exciting, tasty, appealing, and so on. So we can see the connection, right? The tendency of people are going to which part of situation. Or we can do some of the distribution using this pie chart, okay. Or we can have this line graph to see the pattern. Usually this one for bioprocessing, for the productions of something. So we're usually using this microbial growth or product development or product productions, growings of some things and so on. So we can see the pattern. By seeing this one, we already know within 96 hours is reaching the session limits. We already know. If we use the table, then we need to evaluate the value one. Okay, so this is the same thing. right? So how we prepare the graph is very important as well. Huh? It's not that too big, right? It's not that too big. The values, the scales, just now, although inside this one they will have decimal point, but the scale is not necessary to have. It's depending on the, the, the values that we use. Okay, and then we should have a proper legend labelings and okay. For scientific, this one like okay, acceptable, but it's possible try to use like black and white. Let's say you go for journal publication and so on, you still accept the color one, but try to go for black and white because it's not necessary to print out in color as well. Even when you prepare a dissertation, it's good for you to prepare in black and white, not necessary to put into the color. Okay, so the legend, instead of you put this one, you can also put like this in the text inside the caption, but this one might take some time for us to read through. Difficult a little bit to read through. Okay, so you can have put multiple information into one graph. For example, you have this one and you have this one as well too. Okay, so you can see the connection. If the data inside the table might be very difficult for us to see the connection between different variables. So this one you can see the connection between different variables. Okay, so you can also get the data, collecting it, and then you can convert it into the flow graph, flow diagram. Okay, this is material balance, mass balance, or material balance. So we can get the data from our experiments, and then we convert it into the balance. Data from good research versus bad research. If good research, you can see that even we, the lecturer, so when the student present to us, we can see that whether it is good data analysis has been done or not, based on how the data has been generated. So we can clearly see that. Okay, so try to put some efforts on analyzing data and prepare a very good presentation of your data. So that will trigger people on how to see your data. So we can get some conclusion just by seeing your data. Okay. All right. So that's all for this one. Research, do you have any question so far? Okay, I will load this one into the Putra Blast as well later on. To me, it's a good paper because it's involved a lot of methods that we already discussed, a lot of methods that we discussed. Quantitative data, qualitative data, statistical analysis, a lot of inside of this paper that you can use in order for you to understand further on how the research, especially using the survey, has been conducted. It's not like a normal research for biotechnology that doing the wet lab in the lab, right? But using the survey in order for us to get the information. So they are going to have like meat substitute by using the fungi-based protein. How they can get this. Okay, so I don't have to read through all the introduction part, but the main important one, right? This is how they conduct the questionnaire. You see how they conduct the questionnaire. This is a pilot study. So usually when we do the survey, right? But huge project, so we must have like I mentioned to you, we must have a small versions of it, right? To test, to evaluate, to review our questionnaire first. Then we have the pilot test, right? So this is one of the pilot tests that being conducted to prior to the real one. So maybe after this they can conduct further to get the more results, to confirm the data. So they make it for the Europeans, you get the data from UK and Germany, and they conduct this one, right? The survey. The survey is developed using GIS and also distributed through the social media, Facebook and LinkedIn, and also survey cycle, and they also mention why they conduct through the social media. Okay. And this is how they prepare the question, right? So what are the things that they want to ask to the respondent? This particular part, what are the things they want to ask to the respondent? Okay. So the question about hypothetical decision to purchase was framed, how they arrange the question academically, right? And also they also put the statistical analysis. They do some linear regression to measure the influence, non-parametric tests to perform or to determine the difference between groups and strength of association, and the levels of significance. They set p-value less than 0.05. Okay. So this is semi-structured interviews. So this semi-structured interviews for them to obtain the qualitative analysis. They interview people. So how long of it, how they conduct, and so on. Okay. So these are the results. So they arrange it into the quantitative phase and also qualitative phase. So if quantitative, all get values, right? All they have the values. They distribute it into the values. Whether the demographic of the characteristics, the age, the gender, the living location, or the education. This is important because we want to see the people kinds of situation. You can see this one, how they conduct, or what the information needed in the survey form. Okay, so these all get the values, so they are quantitative, and they can distribute it into the after doing some statistical analysis accordingly. And then from this one, right? So this plus minus mean plus minus of standard deviation or standard error. So we need to check on how they conduct the statistical analysis. We need to see this one. All they have plus minus. So it shows that they have done some statistical analysis, right? Okay. And also they have linear regression, and then they also have FTN scores predicted, right? And also they have the PI scores, okay? The significantly model, right? They also do some statistical analysis to evaluate the model. Okay. So this is the qualitative phase. So the qualitative phase, they don't have the value, but they have the statements, right? They have the statements. So this is the statements for the qualitative. So usually they put into the statements what have been informed by the respondent, how the respondent respond to the interviews. And then this is the FTN and PB relationship. You can see how they tabulate, and based on this tabulation, we can see they actually food technology nephobia score to what range, right? So mainly in this particular part, for this particular benefit score. Okay. Right, so this is the p-value, this is a z-square, right? And so on, the median of the I-score, right? So based on this one, the data, the information that they have, they can also convert it into the diagram in terms of the flow, sensory attributes, what are there involved, personal benefits, what are they involved. They can do some predictions here and right into the diagram. These all are qualitative analysis. Okay. And then when they discuss based on the results that they obtain. Right. Plus Patient, what do you mean by heat map? What you refer by heat map? Is it that data heat map? Means that the Earth heat map. Is it what do you mean? Yes, we can. Doesn't matter weather data, heat map data, and so on. As long as that data we can collect and analyze. Maybe heat map over time. So previously to previous years, what are the situation that we collect? So we arrange into the new map so we can see the pattern. So yeah, it's acceptable. The data has no limitation as long as we can collect the data, analyze it, and generate the results. And the results can be used to conclude our objective. Then okay, no problem. All right, Sri, I will record the attendance based on this recording version. Later on, I will do some checking and just record the attendance accordingly. Okay, so class, is there anything else? So if there is no more, I think that's all from my side. Thank you very much for your attention. Meet you again next week. Okay, so anything information next week should be with Prof. Yuno, but I will confirm it again for the big data analysis. I will confirm it again with you guys. If not, then we will skip for big data, continue with my lecture first, and then I will inform you back on that particular part. Okay, class? Thank you very much. Have a nice day, nice weekend. Enjoy your time. See you.
Thank you, Prof.
Thank you, Prof.
Okay, bye-bye.
Prof.
Thank you, Prof.